We're going to be looking at hypothesis testing this week. Um, so the example that I'm going to talk about today is hypothesis testing for the mean when we have just one sample and we know sigma. And we're also going to use a p-value in this example. So the first step in hypothesis testing is to state the claim and the counterclaim. The claim is children in the U.S. watch on average 3 or less hours of TV weekly. So that becomes our null hypothesis because it does contain the equality. The null always has to contain the equality. And so the null hypothesis, h sub 0, is that mu is less than or equal to 3. The counterclaim then will be the opposite of that, which is mu is greater than 3. Now, when one of these is false, the other must be true. Oh, if should say is, by the way. So we're going to set up the test with the null hypothesis that we already stated and the alternative hypothesis, which we call H sub A. We're going to look at a sample of 100 children. We're going to test them, and we discover that the mean of that sample, x bar, is equal to 3.5, and the standard deviation of the population is given to us already as 1.5. So we have a sample mean, and we have the population mean. Now, suppose we choose a level of significance of 0.05. Alpha equals 0.05. That would be 95%. We want to find, first of all, the standardized test statistic, which is z, and then determine the p-value. And if p is less than our alpha, we will reject h sub 0, because that is our claim, remember. All right, so to find z, first of all, we use this formula. Z is equal to x bar minus mu divided by sigma over the square root of n. And just plugging in the numbers, we come up with 3.33. Now, we're going to go to the standard normal table. This is a z value, so you're going to look in the z column for 3.3 because that one's only accurate to tenths. And then we have to move across to column 0.03, and the number that sits there is the area that is to the left of the point that we've determined, and that's 0.9996. So if that's the area to the left, then the area to the right, which is the tail that we're looking at, would have to be 1 minus that. So p then is equal to 0.004, and that's the area in the right tail. And notice that that value, that p-value, is less than alpha, and therefore we will reject the null hypothesis.